All right, so if we're looking at the second part of the homework for real, we did a sample using the first part, mean and standard deviation, but we actually took some time with calculators and calculated the actual mean and standard deviation for that second problem. And the mean was 26.86, but you can see in the problem it says, was it 26.86? But the problem says round it to the 10th place. So we would have to round that to 26.9. The standard deviation was 3.57, which we would round to the 10th place would be 3.6. So we have the mean of 26.9 and the standard deviation of 3.6. $26.9, 3.6. So now we're going to do the same process. And this would be the actual results of the homework. We're going to do the exact same process. So what I do for the excellent category, I take 0.88, I multiply it by the standard deviation of 3.6, add it to the mean of 26.9, and in this case, our excellent group will start with what score?
30.1.
30.1? 30.1. So 30.1 and above will be considered our excellent group. I don't have the whole set of numbers in front of me, so I don't know how many actually scored a 30.1 or above, but we can look at that after. So now I go to 0.28 times 3.6 plus 26.9 equals 27.9 to a 30.0. Anyone scoring 27.9 to a 30.0 would be considered in the good category. And actually these are vertical jump scores. I remember from a research study we were doing. So anyone that jumped to 30.1 or above inches would be an excellent. Anyone jumping 27.9 to 30 inches would be in the good. The average would be a negative 0.23 times 3.6 plus 26.9, and that equals
26.1.
26.1 to a 27.8. So 26.1 to 27.8 would be considered the average category. Now we go down to the fair group. The bottom of the fair group would be a negative 0.81. Multiply that by the standard deviation of 3.6. Add it to 26.9, our mean, and that gives us what?
24.
24 even?
Well, it's 23.98, but it rounds up.
Okay, to 24. So it'd be 24.0 to 26.0. Anyone jumping 24 inches to 26 inches would be considered in the fair category. And then we go down to the poor. We really don't have to calculate here. All we have to do is go to 1/10 below the bottom fair score, which would be 23.9 and below. And those are vertical jump scores, so it gives you a pretty good idea. And actually for males, in the research we've done, the average male NCAA Division I baseball player is going to jump around 27 inches, so that's pretty standard. All right, so that being said, now all we have to do is go look at all of them. I think there were 22 of them. How many? There were 26? Okay, so there were 26 scores. N equals 26, and we just have to ascend them or descend them and figure out how many people jumped 30.1 or above, so on and so forth, and we put that number in there, and that's it. That's how you run.
Can you do that on a calculator, or does it have to be on Excel?
What do you mean?
Can you ascend or descend numbers on a calculator?
I don't know. That's a good question. I do it in Excel all the time because it's simple to do. You just highlight it, hit sort, and it'll sort it from lowest to highest, highest to lowest, however you want to do it. But you may be able to do it on the calculator, on the sophisticated ones. I don't know. So that's the process in a nutshell. And actually, that's the homework assignment, and that's how you do it. But in your quiz, Chapter 13 quiz, you will have to be able to do this. So it's very important that you get it down. It won't take long to get this down. Because once you get, it's always the same, it's pretty straightforward. Once you have the mean and standard deviation, you can quickly go 1.5 times the mean plus the, 1.5 times the standard deviation plus the mean. That'll give you this number. And then all you have to start doing is from this number, subtract one standard deviation, subtract one standard deviation, subtract another standard deviation, and you're set. That will probably take you, once you get the mean and the standard deviation set, take you 2 minutes, 3 minutes tops to do. This one takes a little longer when you do categories, because in categories, you have to actually calculate each individual category. Unlike grades, you really just have to calculate the A, and the rest of them just fall into place. So it will take a little longer. But that's the process, and it's pretty straightforward. Just make sure in the homework or in a quiz, you put for example, in the A, you would put 87 and above, or 87 and an upward arrow. Just designate that anything above that. Some people just spell it above, and that's fine as well. And then you put how many students receive that grade, and you do it for each grade. And in the category, same thing. You put, in this case, 30.1 and above, and how many students scored in that, and the same for each individual category. There you go. It's kind of significant because I think in the quiz it's probably worth 10 points. In your final exam it's worth at least 10, maybe more. So doing this is very important, and practicing it, you'll get pretty good. Many of you, as I mentioned earlier, will use categories far more than you'll use grades. Categories are important. This is the standard category scale, as we said, but there are many different types that you can use. There are 7 category scales, there are 10 category scales, all different types, but this is the normal one. What I don't like about this is because excellent is from 81 to 100, and that's a broad range. I'd rather see 90 and above, or 95 and above, or maybe 90 and above be considered superior, or some other grading scale. Because getting an 81 and getting a 100 is vastly different to me. It doesn't discriminate very well. And in statistics, as we've mentioned before, we want discrimination. We want to be able to clearly define performance. And this kind of groups people in a big 20% category. That's pretty big. So, but it still works for most situations. Okay, questions? All right, well, it's just a matter of knowing the process. I would obviously keep this in your notes, because this is always going to be the same. This will always be the same for the purposes of testing in this class as well. So keep that part right there. This will change depending on the mean and the standard deviation, as well as this part will change depending on the mean and standard deviation. As long as you have that mean, as long as you have that standard deviation, you can make sense of any data set with this simple system. So hopefully that'll help you out. All right? Okay, go get 'em.